All right, Algebra 2 kids, this is section 1.3, which is rate of change and slope. You guys have probably heard of the word slope before, but rate of change is just another term for that. Rate of change is a lot of times used in like story problems and things like example 1 and example 2. Rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. And we always represent the rate of change or the slope as the change in y over the change of x. You guys have probably heard that as the rise over the run. The coordinate that rises is the y coordinate, and the coordinate that runs is always the x coordinate, okay? So it's rise over run, or the change in y over the change in x's, okay? So the first example they're talking about as temperature is increasing, time is increasing, or time is going by, what is happening to the temperature? The temperature is getting lower if you look at this table here. So after 2 minutes, my temperature has decreased, and so on and so forth. So I'm just going to look at this table. It's asking us to show the temperature of a solution, find the rate of change in temperature for the solution, okay? So looking at the x coordinates, which is this first column here, the amount of time that changes from 0 to 2 is just 2 minutes, right? And the amount of time that changes from 2 to 5 minutes is 3. 5 to 8 minutes is a change of 3 minutes, and 8 to 12 minutes is a change of 4. Okay. Now, looking at temperature and how temperature is changing from 143.6 degrees to 139.4 degrees is a drop in 4.2 degrees. If you do that on your calculator, it's going down 4.2 degrees. Going from the second to the third, so 139.4 to 133.1, that's a drop in 6.3 degrees. The next one is also a drop in 6.3 degrees, so I represent that as a negative 6.3, going from this 133.1 to 126.8. And then from 126.8 to 118.4, that's a drop in 8.4 degrees, I think is what it is. Yeah, 8.4 degrees. So we're looking at the change in temperature, and we're looking at the change in time. Now, when we're dealing with rate of change, at least for this for this section, all of the rate of change will be the same. Except in this column right here, we're looking at the rate of change, and we're seeing that 4.2 is not the same number as 6.3 and 8.4. They're all different, okay? And you might be wondering why that is. Well, if you look at the x coordinates, from a time of 0 to a time of 2, I've waited 2 minutes and I'm testing the temperature, okay? But then the next time I test it isn't again until 3 minutes later, okay? So I'm going to have a larger drop in temperature the second time after the second time I test it, okay? And then I'm going to have a really large drop in temperature from the 8 to 12 minute mark because I've waited 4 minutes to test the temperature again. So what we're going to do is to find the rate of change is we're going to look at how much it's dropping per minute, okay? So it is dropping 4.2 degrees in 2 minutes, okay? This is like the rise. It's rising a negative 4.2 for the run of 2 minutes, okay? Same thing again, negative 6.3 over 3, because it's dropped 6.3 degrees in 3 minutes. That's the y coordinate over the x coordinate again. Negative 6.3 again divided by 3. And negative 8.4 divided by 4 is the last relationship that I have, okay? Again, that's the y coordinate over the x coordinate. The y's are the second column, the x coordinates are the first column, all right? Now, if I look at each one of those, and if you take in your calculator, or you can do this mentally, negative 4.2 divided by 2, that's dropping 2.1 degrees per minute, okay? If it drops 4.2 degrees in 2 minutes, it's dropping 2.1 degrees in 1 minute, okay? Now, you'll look at these other three, and you'll notice that, hey, if I divide, that's also negative 2.1. And that's also negative 2.1. And the last one, 8.4 divided by 4, negative 2.1. Okay? So there is where my rate of change is constant, okay? All of them are negative 2.1. So even though it doesn't look like it over here, that's because I have to divide by the amount that it's changing in the x coordinate, okay? And all of those are going to actually end up being the same rate of change, okay? So when they ask for a constant or for your rate of change, you're going to look at that y coordinate divided by the x coordinate, or how much the y is changing in comparison to how much the x is changing, okay? For the average rate of change here, it says refer to the graph at the right, find the average rate of change for the sales for both digital music and ebooks. So we're going to end up doing this twice. So this is going to be digital music. I'm going to figure out what that rate of change is, and I know it's going to be some value over another value. For ebooks, I know again it's going to be some value over some value, and we're just going to look at how this value is changing. The ebooks you can kind of barely see because it's just really, really, really close to that bottom line there. So we'll look at what's happening there. But they want us to go from 2004 to 2009. So we're looking at the first date here, 2004, and what's happening in 2009. All right. In 2009, for digital music, I'm at $3,100, where I started at $200. Okay. So what I'm going to do is I'm going to look at the change of y. How much did it increase from 200 to 300 or 3,100? 3,100 minus 200 is how much it changed in the y coordinate, and that is 2,900. Okay. If I'm looking at how many years have elapsed, or the run, how many years have gone by, that's 2009 minus 2004, or just 5 years. Okay. So 2,900 divided by 5 is 580, I think. 580. That is how much money it is increasing per year. So that's my rate of change of digital music on average, 580. I'm looking at the starting point, the ending point, comparing how much the y coordinate is changing on the top here, how much the x coordinate is changing on the bottom. Okay. For ebooks, this value right here is 9.6. 9.6, and then 1.6, or excuse me, 165.8 is where it ends up at. So it's going from 165.8, and I'm going to subtract 9.6. Okay, that's where it starts and where it ends. Okay, and again at the bottom I have 2009, and I'm going to subtract 2004. Okay. So my bottom number should be 5 again, but my top number, if I subtract that, 0.2, let's see, 156.2, I think is what it should be. Okay. If I take 156.2 and I divide by 5, I don't know, 31.24, maybe. $31.24. I don't know. You check that and make sure in your calculator. So you can look at the rate of change of digital music. It's increasing $580 per year versus ebooks is only increasing $31.24 per year. If you think that's not a whole lot of money, it's actually really in millions of dollars, because that's what my rate is here on the side. So $580 million really in comparison to $31 million is what is increasing per year in ebooks. Okay. So rate of change is the y coordinates over the x coordinates, or how much it's rising over how much it's running. You should probably be familiar with the slope formula, which is this next one. It's essentially what we just got done doing. If you can't see this very well, this says y2 minus y1 over x2 minus x1. Okay. Y2 and Y1 just stand for the first Y coordinate in an ordered pair and the second Y coordinate in an ordered pair. Same thing with the X2 and X1. First X coordinate, first Y coordinate, all right? So they're going to give us an ordered pair down below in example 3, and they want us to find the slope. So we're just going to use this formula, or this equation, Y2 minus Y1 over X2 minus X1. And I'm going to go ahead and label these at some point, or you guys might be able to already do this without labeling. Negative 4, 3 is going to be my first x coordinate and my first y coordinate. So negative 4 is x1, 3 is y1 because an ordered pair is x comma y, okay? 2 is going to be my x2 and 5 is going to be my y2. So my second x coordinate and my second y coordinate, all right? I'm going to plug that into the equation up here. So I'm going to take the second y coordinate, which is 5, and I'm going to subtract the first y coordinate, which is 3. And I divide that by, or put that over, the second x coordinate, which is 2, minus the first x coordinate, which is -4. Be careful with your double negatives. You can have a double negative in there. Minus a -4 turns to +4. And you're going to have 5 minus 3 is 2. 2 plus 4 is 6. Or 1/3 is your slope from those 2 points. Okay? So from -4, 3 to 2, 5, 1/3 is the slope. Okay? Remember that the y coordinates go on top and the x coordinates go on bottom. That's the biggest mistake I see algebra kids make, is that they'll put the x's on top because the x's come first, right? But the y's are supposed to go on top. So make sure you put the y's on top, all right? And this next one, example 4, find the slope using a graph. Find the slope of the line shown at the right, okay? Now, one of the first things that you'll notice about this line is that it's going downhill from left to right. And that's going to reflect a negative slope. Okay, so make sure that when, in the end, your slope ends up having a negative in front of it. Okay, I don't know if I mentioned up here, but slope a lot of times is represented with the letter M. So if you see that in your homework assignment, M stands for slope. Why, I don't know. I don't know why it's not S or something different, but slope is represented with the variable M. I don't know. So we've got a negative. And what I'm going to do is on this line, I'm going to pick 2 points that go through this exactly. So I see this dot right here. It's going through that dot exactly. That is the point -2, 0. Okay. And then I see down here, this is going through the point 0, -3. Okay. So from this point to this point, from left to right, this point to this point, I am looking at how much it's rising over how much it's running. Okay. This is actually going down 1, 2, 3 units, okay? And that is represented by a -3. That's where the negative comes into play, -3. And it's running 1, 2 units, okay? So -3 over 2 is my slope. I can tell that from the graph. And I just did that by counting how many it's rising, how many it's running, okay? I could also do that by plugging this -2, 0 and 0, -3 into the slope formula up here, y2 minus y1 over x2 minus x1, and I should get -3/2 also. So either way will work, but a lot of times you won't have the graph. You'll only be given the coordinates, so you'll have to use the equation. All right? I'm going to do a little bit of added information here before I move on to section 1.4. Sometimes you will have a graph where you have a line that looks like this. Maybe this is crossing through at the value of 5. Okay, this line right here is crossing through the y-axis. The y-axis is what goes up and down. Okay, so it's cutting the y-axis at 5. So the equation of this is actually y equals 5. I'm getting a little ahead of myself by telling you that, but you'll see that later on. So I'm going to expose you to it now. This equation, y equals 5, if we try to find the slope of him, of a straight horizontal line, the slope of a horizontal line is going to be 0, okay? Now, if we compare that to a vertical line, so here's what a vertical line looks like. Let's say this vertical line is it's crossing at -2, let's say, on the x-axis, okay? This vertical line is cutting the x-axis, okay? So the equation for that guy is going to be x equals -2, all right? Because it's cutting the x-axis. His slope is undefined, okay? So you might see in your homework assignment, I don't think they do it to you this section, but we'll eventually get to a point where we talk about slopes of 0 and slopes being undefined. Those are referring to horizontal lines and vertical lines. So this might be something that you want to add to your notes so that you can get that information now, and it'll be easier for you to understand later on. Okay, and that's it for section 1.3. That was slope.